Hey everyone, I'm Joshua Deemer, and welcome back to Lesson 14 of our Java Programming Tutorial series. Let's jump right into the lesson. Let's go ahead and take a look at some code that I've made here and discuss encapsulation with it. So I've made a player class where I have maximum health and maximum food, the kind of generic information like username, X, Y, health, and food. And then I have a constructor which takes in a username, and everything else has a default value, 0, 0, max, max. Okay? Inside of main, I have a scanner which runs through a do-while loop to get a username from the console. And so if it is successful, I trim it. If it's successful, meaning that the length is 3 or more, that means there's 3 characters or more, then it will set the username to this temp username. So it'll be outside of the while loop. It'll continue until this username is set. Then, here we set the new player and set it to the username. We report the player, and the player is reported with this information. Okay? So if I run this, and I type, say, Joshua, it'll say Joshua, 10 out of 10, 10 out of 10, and 0, 0, which is all correct. Now, the way that encapsulation works is, let's say you want more hidden data, more flexibility, less redundancy, whatever it is you want, let's say you want that. So, firstly, what you would do is you would start by making this private. Now, I understand that this will cause an error over here because we can't get the username anymore. However, the way that you can make it so you can get it is you can say public string, so the data type that this is, and you say get username. You make a method that gets the username and you return that username. So the benefit of this is that you can still get this private variable because this is public. If you made this into private, then it won't be able to, the main class won't be able to find this method. But since this is public, you can still get the username, but you won't be able to set it anymore. And so now you have that flexibility specifically. So now if I say get username instead, it'll run the get username method, getting the username without needing to worry about people setting the username. So if I run this, it says please enter your username, Joshua. And it still says Joshua. That's how encapsulation works. This is called a getter. If you wanted a setter, you would say public void set username, and then you would put in your parameter here and say this.username equals username. But unlike keeping this public, you can actually have it so that, for example, here, if we were to take this and copy and paste it into here, where we're checking if the username's length is less than 3, we can now verify that this is actually going on before setting the username. So then we could say return here if the username's length is less than 3, and then it won't set the username. So we would have more flexibility here. But this is called a setter, and this is called a getter. And you can do this for each of these if you'd like. In fact, it is preferable and good practice. You can have public variables, that's perfectly fine, but I almost always like to use encapsulation with getters and setters. So I'm actually going to remove this because I only want it to be set inside of the constructor. Okay, so I'm going to say down here, public int get x, then we return x, public int get y, return y, public double get health, return health, and public double get food to return food. We have the getters for every single one of these now, so now they are accessible to get, but they are not accessible to set. Once they are set inside of this class, they're kind of set permanently. I'll fix that in a second, but let's go ahead and fix these first. So get health, I don't know why I copied it, get food, and get X, and get Y. If we run it, enter your username, Joshua, and now it still runs just like before. However, now we cannot set any of these, okay? This allows you to be a little more strict with the class. So for example, now you can say public void move int x, int y. And so this would say x plus equals, or sorry, this dot x plus equals x, and this dot y plus equals y. And so now the player can only move. You can't just set the variable, it adds to the variable. And so we can flexibly make it do that, right? So now if I say in here, player.move, we'll say 10 and -5. If I run this and I type my username, it'll say 10 and -5. So even though the variables are private, I can dictate what the class is allowed to let out and what the class is allowed to set in this way. It's a lot more understandable, especially out here. I mean, of course, I could simply say player.x equals 10 and player.y equals -5. Or if we want to be real strict, plus equals. But seeing player.move makes more sense in our minds, and we can understand, okay, we're moving the player a certain amount of X units and a certain amount of Y units. Now, one other thing we can do is we can actually make this final. We don't want the user to change their username. There's cases where you do, so don't think this applies to every situation, but we can make this final because we don't want the player to change the username. Once it is set inside of the constructor, we want it set permanently and never changed. And so there's no problem in doing this. You can do something here saying Joshua, but then an error will be thrown here because a value is already set. Doing it like this is okay because the constructor sets it. If I removed this and we never set the username, you'll see an error is thrown and it'll say initialize the final field variable in the constructor. And so now there's no error. Okay? So it is important to set your final variables, whether it's in the constructor or in line with it. So I know I said that this episode is about polymorphism as well, but I'm gonna just go over the beginnings of polymorphism, such as method overloading. I'm gonna go ahead and also change, if I can spell, these to double. Okay, and of course that means I'm going to need to change these return types to doubles because you can't convert a integer into a double, or a double into an integer. There we go. So how does polymorphism work here? Well, let's actually go back to our main class and see what we can do with polymorphism. If I were to say private static void add numbers, okay, int x, int first, and int second, then we could say system.out.println first plus second, right? So if I say add numbers, we'll actually just comment this entire chunk out for now. And we say add numbers up here. And we'll just say 10 and 20. If I run this, obviously it's going to print out 30. But what if I wanted to have different types of methods with the same name? Well, if I go ahead and copy and paste this, You notice there's an error because because Java doesn't really know which one to pick to run, right? However, if I were to say double here, there's now no longer an issue. It knows which one to pick because of the parameters. So, since I said int here, and I put in int here, it's going to run this add numbers. But the moment I change these to decimal numbers, to doubles, you'll see that this method is yellow, meaning underlined in yellow, which means that it is never used. And this one is going to run now. So if I say 10.5 and 20.2 and run it, it's actually going to run the double one. But again, if I remove it, in fact, let's make this even more obvious. Double and int, and surround these in parentheses so that they actually add together as integers and doubles, and run it, it'll say the int for 30. If I say 0.2 and 0.1, it'll say double. So Java knows what one you want to use because of the parameters that you can put in. Now, you don't need to just match the parameter amount. I could add another one, and you'll see that it has issues here. If I said int, you'll see it has issues up here. I could go int double if I wanted, and then double int if I wanted. But let's also go ahead and say int third. I now have a third parameter that I can use. If I press Ctrl Shift Space, you'll see that there are 3 different types of methods I can use here. And if I want to use this one, I can say it. It's going to say an error because these aren't integers. So real quick, this is going to be int triple. If I run this, it'll say int triple. Okay, cool. So you can use it like that. You can also use it inside of constructors. And so if I go to our player class here, I can also say public player string username int x int y, or sorry, it's doubles now, double x double y. And I can say this dot username equals username. I can say this dot x equals x, this dot y equals y, and then health equals max food, not max food, max health, and food equals max food. And you'll see there's no errors. If I were to remove these two, of course there would be an error here because it's matching this constructor and doesn't know which one to choose. Now if I go inside a player here, I can see that there are 2 different types I can choose from. The one with the x and y being set, and the one with no x and y set, which will automatically set them to 0. So if I run this with them set like this, it'll actually run the other constructor, the one with the double x and double y. Okay? And again, you can do this. String username, double. You can do this as many times as you need, as long as you don't copy another method. So if I say double health and double food, I can then set them all inside of here. This dot health equals health, and this dot food equals food. And if I open it up, you can see that it has another overloaded method, and not args, and I could say 105 if I wanted. If I run this, you'll see that the health is now 100 over 10 and 5 over 10. Okay, so you can definitely make this as flexible as you'd like. The only thing you can't do, so let's say we have this move here, okay? you can't say public int move, int x, int y. Just because the return type is different does not mean that Java will know which method to use. So you need to make sure that your parameters are different, not your return type. Okay? Now this is a more simple form of polymorphism. It's method overloading, but we will be going over more complicated polymorphism in future episodes. So for practice, I want you to create a main and player class. In the player class, I want you to populate it with some fields, up to you how much you want. I would suggest 3 or more. And have 3 constructors inside of it to practice method overloading. Okay? Then I want you to make the fields for the player class private and have getters for every field and at least 3 different types of setters. So let's go ahead and get into this. I'm going to move this over here so I can see it while I'm making stuff. If you want to do it on your own, yeah, pause the video now, but otherwise we're going to go through it together. So I'm going to create a new class, call it main. I'm going to create another new class called player. Let's do the player class first. So I'm going to say private. I don't care about the username right now, so I'm going to say int x, private int y, private double health, and private double food. In fact, I'm just going to use 4 integers. Then I'm going to say public player, and in here we're going to say nothing. Nothing's going to run. Then we'll have public player, which is int x and int y. This dot x equals x, and this dot y equals y. And we're going to say public player, int x, int y, int health, and int food. And I'm going to say this dot x equals x, this dot y equals y, this dot health equals health, and this dot food equals food. I do want to point out that while you can have method overloading, right? If you were to say have the same variable types and different names, this still does not work out because Java won't know which one you're choosing because it doesn't really know, oh yeah, we're choosing the one with health and food, not the one with X and Y. It looks at the data types, not the variable names, so keep that in mind. Okay, so we got that all set up. I don't really like how that looks though, and I don't like typing it out every time. In fact, how do we set food and health here? Why do we have to set it all here? So what I'm going to do is say private void initialize. And in here, I'm just going to take in everything. Int x, int y, int health, and int food. And in here, I'm going to say this dot x equals x. This dot y equals y, this dot health equals health, and this dot food equals food. Then all I gotta do is I just gotta say initialize x, y, health, food. And then I just need to do it here as well. Initialize x, y, 10, 10. Default values, right? We got initialize 0, 0, 10, 10. Another way I could do this is just by saying this, then in parentheses I put 0, 0. That'll do is it'll actually call this constructor next, and then it'll run this. So if I say this xy 10, 10, it'll now run this constructor for us. So this constructor runs, it calls this constructor, then it calls this constructor, then it initializes. Well, at this point, we don't need this initialize method anymore. But having this is helpful to some degree in more advanced projects. Okay, that's why I did it, so you guys could see it. Okay, so now we are able to set the constructors. What's up next? We made the fields, we made them private, having getters for every field. So we got public int get x, return x. We have public int get y, return y. And we have public int get health, return health. And public int get food, and make it return food. Now, one thing I like to do is categorize my classes to where it is constructors. So, for example, the constructor start and constructor end. And then here, I like to have my getters. Getter start, getter end. But before getters, I like to have my setters. So setter start and setter end. And then above the setters, I like to have the other types. So I'll just say miss start and miss end. So like, for example, public void report. That would be technically under miscellaneous. It could be seen as under a setter, I guess, but I just put it as miscellaneous. Something like have something internal run for the player. And then under here, I like to have overloaded methods, or sorry, overridden start. So overridden methods down here. We have not gone over overridden methods yet, but we will very soon. It'll be in one of the next few episodes. So we need 3 different types of setters. So public void move. We can have move. Then this would be this.x plus equals x. This.y plus equals y. Then we could have heal. Int amount. This would have health plus equals amount. Public void feed int amount, and we could have food plus equals amount. Now, like I said, this is a lot more flexible than simply making this public, right? What you can do is you can say if food is greater than 10, then food equals 10, and now you have a limit added. And you can say if amount is less than or equal to 0, then return, so that if this number is a negative number or 0, don't do anything. There's a lot more that you can do to make sure that this data is validated, okay? But we have completed what we needed to. I just kind of wanted to show you how I have things set up. But inside of main, we can then say player equals a new player. And we have 3 different constructors we can choose from. We can leave it blank. We could have XY or XY and health. I'll leave it blank for now. And we can say, we could say something like player dot. Come on, player. What's wrong? Player dot move. Right? Something's wrong here. Added that. It's just throwing a hissy fit for no reason. So 10 and 5. Oh. Silly me. I forgot the main method. Okay. Player equals new player. There we go. So player.move. There we go. So if we do 10 and 5, we can also do player.heal, an amount of 5. and player.feed an amount of 2. And then down here we could say system.out.println player.getX plus comma plus player.getY. And then we can say player.getHealth player, just something simple, get food. If I run this, it'll say 10 and 5 because we moved the player to there. If I were to say have -5 here and run it, it'll now be 5, 0 because we have a default value for the X and Y. But when it's blank like this, we have them set to 0. And so it passes 0 into these, and it passes 10 into these. Okay? But it looks like it works fine. We start with 10, this adds 5. And then we start with 10, this adds 2, and so works perfectly fine. That's the end of this episode. Next episode, we will work on our second project in Java using what we've learned so far. The project is a little more complex than the previous. We will be creating a Mad Libs game and store the result to a text file. Thanks for watching. Feel free to comment what your thoughts are on the series so far down below. Don't forget to like, subscribe, and ring the bell so you don't miss a video. Bye!